in there that we're square rooting a negative, and it has this weird phrase. It says over the complex numbers. What do you think that means? Any thoughts? It's kind of weird wording. It's normal wording for mathematics, but it's kind of weird wording for everyday language. Basically what it's saying, it's kind of indicating to you that you're going to have to use that number system in order to solve. And we say over, meaning within or using the complex numbers is kind of what that means. Okay. Of course, we know to get x by itself, we need to square root x squared. And then do the same to the other side so that it's balanced. Don't forget your plus or minus. And we're going to split square root of 64 times square root of negative 1. Why? Right. Yeah, because we can't square root a negative number, so we define a number called I as the square root of negative 1. This lets us bypass that issue. So obviously square root of 64 is 8, so positive or negative 8, and then square root of negative 1 is I. So 8i and negative 8i should both be selected. When it says select any that apply, usually they want you to pick more than one. All right, raise your hand if you got that one. Come on. It should be like A and D, like that's the two letters. Okay. All right, next one. So by the way, this warm-up covers what we did last week on complex numbers in some sense. So the top, that's solving, which it definitely gets more complicated than that. You've seen that. And then this is operations, specifically multiplying. Okay, so we just distribute, and we'll get 4 for 2 times 2, and then negative 7i, and, sorry, not 7, 14. Negative 14i, and then 14i, and then negative 49i squared. And combine your like terms in the middle. Those become 0. What is I squared? Okay, so this is 4 minus, and then 49 times negative 1. I'm putting that in parentheses so we know, just keep track of the signs maybe a little bit better. And so that's 53. Now I feel like we've had that version before of some sort. What are the two called? What are those two called? Complex conjugates. And we specifically use those when we are simplifying quotients because it does turn out to just be a number instead of a complex number. It turns into real. All right, raise your hand if you got B on that one. Great, good job. Lots of hands. Let's check that homework. So pull it out, we'll go over those answers. All right, started on 30, so 6 plus 6i. 31 is 3/4 minus 1/4 I. 32, 4 minus 2i. 33, negative 4/5 minus 8/5 I. And then also 46 was... A was 14/17 plus 12/17 I. That was a lot. Part B, you should have got R sub 1 plus R sub 2 over R sub 1, R sub 2. Sub meaning subscript, right? So R1 plus R2 over R1, R2. And part C, if you choose R2 to be the complex conjugate of R1, the total resistance will be a real number, which is 5/2 on that. So How'd you do? Any of those you'd like me to do? Yeah. Okay. Just one thing to point out before we start is here's a real world application of this complex number system, right? So resistance. Has anybody ever taken a class where you learn circuit diagrams like this? It's cool, right? I mean, I think it's neat that we've figured out ways to even show in a diagram how electronic stuff works. It's cool. Anyway, you can see here the zigzags are the resistors in the circuit. Anybody know what that is? Yeah, good job. A battery. Okay, ohms, just for those of you who don't know, ohms is the unit that we use to measure resistance. So just like feet is a unit of length, this is what we use to measure resistance. And resistance is something that you use every day. So you turn on your stove to heat up some mac and cheese or whatever. It's using resistance against the electrical current to get hot. That's just one example. Those are all over the place. But anyway, so part A, find the total resistance. Write your answer in the form A plus BI. So what are we doing with this kind of intimidating looking equation? What do we do with it? Actually, I don't need to write it again. There we go. What do we do with this? Just plug in the resistance, right? The 2. So 4 plus 2i, 1 plus I goes down there. And now we need to add to find R sub t, which is the total resistance. How do we do that? We can't without, well, these are fractions currently, so we can't just add them together. Yeah.
Do you multiply them by the complex conjugate of one of them?
Okay, let's do that. Well, okay. You said of one of them, and I would suggest doing, let me write this, then I'll see. I would suggest doing the complex conjugate for each one. Since we're multiplying, when we do the complex conjugate, we're multiplying by 1. It doesn't change anything, right? So what is the complex conjugate of the first one? Yeah, so 4 minus 2i. How about the second one? 1 minus I. Okay, I'm going to put parentheses around all that just to keep it a little bit cleaner. Okay, so on the numerator, 4 minus 2i. And then what does the denominator become? Let's see if we can just talk through it. So 16, and then the 2 I terms cancel, the 8 and the 8 and the negative 8 cancel each other. So it's 16 from the 4 times 4. And then we'll get negative 4i squared, which is what? Positive 4, right? So this pages come out of a book and they just don't give you much room. So here's what we have in the denominator. 16 plus 4 is what it becomes. So it's 20. All right, next one. Let me write the numerator. 1, this thing is jumping around. 1 minus I. Okay, so we get 1 from the 1 times 1. The negative I and positive I cancel. And then we get negative I squared, which is actually what? Positive 1, right? So it's negative, and then I squared is negative 1. So it's just positive 1. And let me write 1 plus 1 minus I squared equals, it's actually 2. I shouldn't have written 1. Okay. So that was Joe's suggestion to multiply by the complex conjugate, which was a good one. But are we ready to add yet? No, because we still don't have a common denominator, right? It's just going to be a lot easier to get a common denominator. And what is our common denominator? Between 20 and 2, what should we use for a common denominator? 20, right? The 2 goes into 20. What do we need to do with the second fraction in order to make it a denominator of 20? Yeah, well, by 10 over 10. Okay. So I'm going to just combine the numerators now. Tell me if I skipped too many steps, please. And I will explain. Does everybody understand what I did there? Okay. All right, now we combine like terms. So now we're adding 4 plus 10, so that's 14. And then negative 2 and negative 10. That's negative 12. Okay. Do we know the total resistance yet? Well, it's the reciprocal, right? Do you see what I mean? Like this is 1 over t, or r of t. So we just need to kind of flip both is really the informal way of saying that. So r sub t is 20 over 14 minus 12 I. And now we need to rationalize that. So I would recommend before you do that, do you see how those two can cancel, or not cancel, but simplify, like reduce a little bit? And so can those two, because something goes into 20, 14, and 12, which is what? 2. So this will look a little bit better. So 10 over 7 minus 6i. I guess it's sort of better. And then let's multiply by the complex conjugate. Joe, is this more than you bargained for?
A little bit.
So 70 plus 60i in the numerator. And what do we get here? 49 minus 36i squared. Sorry. So that's 49 plus 36, which is what, 85? Okay, and then what goes into 70, 60, and 85? Like what can we simplify in all of those? 5 does. So 70 divided by 5, what was it? Did you say 35? Yeah. I think it's 14, actually. And then 60 is 12, and 85 is 17. So there's the book answer, 14 17ths plus 12 17ths I. Yeah. Anyway, by a similar process, Joe, I'm not going to take time to go through. I'll just tell you what to do on this second one. Basically, you're doing this whole process, only not plugging in anything for these two. It's kind of just doing a little bit of algebra 1 on fractions. So find a common denominator, add them together. That's all that second one is.
Okay.
And then this one we already read what to do. So just do the complex conjugate to get that real number instead of this imaginary one. Yeah. Does that kind of help?
Yeah.
Okay. That single part was kind of a beast, huh? Did anybody get it? Part A? Okay. Well, if you tried it, good job. That's awesome. But just know that those things floating around in every electronic device you own Like they're being designed with this complex number system that you didn't even know existed till like 10 days ago. Cool, right? All right, well, give me a fist of 5. We're going to break it into 2 sections. So fist of 5 on solving. And just to remind you what that can look like, let me zoom in on those. So take a look at those just for a second. If you know immediately what you would do in the steps, that's what I'm asking. So fist of 5 on that stuff. Okay, that's very high. Awesome. And then let's do these 3 sections: add, subtract, multiply, and simplify quotients. So fist of 5 on that kind of stuff. Okay, still very good. All right, awesome. So you know that we're coming up on our Unit 2 test, our Unit 2 exam over the whole unit. It's not probably going to be this week. I don't think we'll get there. But next week, we'll get there for sure. So make sure that you keep this stuff fresh and you're studying it. Our next topic, we have 2 more. This is called completing the square. So grab your notes, whatever you're going to write on, and let's get into completing the square. All right, guys, basically what we have left is 2 very related things. They're related to each other, and both can be used to solve quadratics. In fact, any quadratic can be solved by these 2 methods. Completing the square being one, and then the last unit or last section, is quadratic formula, which comes from completing the square. Completing the square can also be used on functions to write in vertex form. So, for example, you saw me just write one. I'm just going to make one up. Let's say I have that. If I said write that in vertex form, which looks like what? Just as a reminder. Hopefully that comes to mind right away. What is it? F of x equals a x minus h squared plus k. So far we haven't been able to do that. Not like we're about to. There's kind of a workaround. But if I gave you this first form, which is called what? Okay, that one's standard form, and I said write it in vertex form. We haven't actually done that yet. So completing the square is one way to do that. I'll show you both ways. One of the ways you probably could figure out right now if I just said here, figure it out. But this is another one. But also, like I said, completing the square will allow us to solve and solve anything that's quadratic. So how would you solve this one? You don't have to write it down. Just think through. What are the solution or solutions of this quadratic? What would your first step be? Note there is a bx term. That should tell you one strategy that you should try. Okay, let's try star. But what do we do first? Yeah, we need to set equal to 0. I'm going to reorder it. I like to keep the x squared on the left side. And what do we get there? 25. 24. Okay, so we pause there, and Dahlia suggested star, which is exactly what you should look at. And the reason why is because there is a bx term, the term with just an x. Are there factors of 24 that add up to 12 or add up to 14? In other words, can we star it? Okay, so we're looking at factors, just to remind you, of A times C, in this case 24, that add up to 14, which is B. And that would be 12 and 2. What do we check for before we go write it into factors? Yeah, can either of those be reduced? That's our check. In this case, no. And so we just write them out as factors. Okay. That's been our typical process. In fact, other than square rooting, that's been the only thing that we've done when we have a BX term. So the question becomes, what if we can't? So look at this one. If I said do star on that one, let's just set it up so you know what we're looking at. What is A times C? Negative 11. What is B? And then A is 1. Are there factors of negative 11 that add up to negative 6? No, because the only factors of 11 are 1 and 11. So it doesn't work. Star fails us there. That's too bad. So this is why we're learning these last two strategies, is because we still need to be able to solve these even though star factoring doesn't work. And so completing the square is the process, one process that will do that. You guys, some people love this and that's kind of their go-to, and some people don't, and then quadratic formula becomes their go-to. It's just personal preference. I am of the camp of quadratic formula because it's a formula. You just plug numbers in and you crank through it. There's not as much thinking. I like completing the square. I think it's cool. But here's our goal. I'll just tell you in words and then we'll go write it down. Our goal is to make this number, so in this case our negative 11, we want to make it be a number that we can square root, sort of, think of it that way, so that we can split this into two of the same groups, what we call binomials, and write that in vertex form. If these are the same, I'm not saying this is what it is for this one, but let's say it was like 2x minus 4, 2x minus 4. We could write that as 2x minus 4 and squared. And now it looks kind of like that piece of vertex form where we see h. Okay? And then we can solve it by square rooting. And that's a workaround for us when we can't factor. So let's go put this one. I'll show you the process. It is a little bit involved on the surface, but you'll get the hang of it. So just be patient. If you need, I realize here I'm at the end of my packet, so if you need another page, there's a bunch over there by the fan. Feel free to grab some and you can staple it after class. What? That's not what I want. All right, so there's your title for this section. We're going to do an example where A is 1, and then I'll show you what to do when A is not 1, which complicates this a little bit. That's why we're starting with the easier case. Okay, I think it's helpful to start with our goal. So our goal is to make this what we call a perfect square trinomial. So we can write it in vertex form and solve. Are you writing or talking? You don't want to miss this. You're missing it. Okay, our goal is to be able to make this a perfect square trinomial. I'll show you what that means in a minute. And then from there we can write it in vertex form and solve. Okay, step 1. Move C over to leave ax squared plus bx alone. What is C in this one? 11. And sometimes you'll start with it over there, like all on the other side already. So we have ax squared minus bx by itself. Okay. Our goal, again, is to fill this in. Now you can think of this on the left side, you can think of it as not having a c value anymore. So we want to fill in a c value such that this left side becomes a perfect square trinomial. And a perfect square trinomial is where, let me just show you an example of one. Okay, so if I write this out, I get, like if I multiply it out, I get x squared plus 6x plus 9. And you could think of it as being able to factor it into two identical factors. So this thing is called a perfect square trinomial. What it means is the first term is squared, the last term is something squared, and then the middle term is just the sum of those two pieces, in this case 3x and 3x. So that's what a perfect square trinomial is. And it comes from being able to write it as one factor. In my example, it would be x plus 3 times itself. So one factor squared. That's what we're trying to get. Okay, that is not the factoring for this one, but that's what it looks like. Okay, so we move C over, second step. To both sides, we're going to add b over 2 whole thing squared to both sides. So out to the side here, I'm going to write b over 2 equals negative 6 over 2, which is negative 3. b over 2 squared is negative 3 squared, which is what? 9. Okay, so we're going to say add 9 in here. Why do I have to add it to the other side as well?
So it's still true.
Yeah, we can't just do stuff to one side and hope that it stays balanced. We have to do it to both sides. So plus 9 in this case, we have to add that to both sides. Everybody clear? Okay. What we just did is forcing it to be that perfect square trinomial on the left. Because look at that. If I said factor that, what would you factor it to right now? What would my factors be on the left? X minus 3 times x minus 3, right? It's two of them. So we are forcing a perfect square trinomial. Then we just do it on the other side so it stays balanced. Otherwise, we don't have an equation anymore. And I will tell you, this is always the same process. That's why I wrote it in the note, or the steps, as b over 2. Whatever b is, you're always going to just divide it by 2 and square it and add it to both sides. Now, when a is 1, that changes slightly, but let's just get there in a little bit. Okay, step 3. Rewrite. I always do this on the left side. It doesn't always set up that way, but I make it. So you can do that too. Rewrite the left side as x plus, and then whatever b over 2 was, the whole thing squared. Okay? In other words, factor. Okay, that's all we're really doing is factoring it. I'm just telling you that it's always going to be x plus b over 2 every time. Okay? So here that's going to look like this. X, b over 2, we wrote over on the side, was negative 3. So x minus 3, whole thing squared. On the other side, 11 plus 9 is 20. Everybody clear on where I got that? And we kind of already asked this question, but if I told you to factor this, this is what you would get. Okay? Just if you want to see that. And if you want to write this out, if you factor x squared minus 6x plus 9, you get, and you can do this on your own if you need to, but you'll get x minus 3 times x minus 3, if you do the star, which is x minus 3 times itself, or x minus 3 squared. Okay? Okay, and then last step is to move the other side back over, in this case the 20. Actually, you know what? Pause there. I want to go ahead and give you the two options that you'll have for this, because it depends what your goal is. So maybe I'll give you two different options at that point. But let's make sure that we're clear on how we got to this point. Any questions on how we got there? Okay. So here are your two options at this point. I need to get rid of some of this lines for mine. I always write too big. Okay. If you have room, at this point you have two options. It depends what the problem wants you to do. You can solve, or you can write in vertex form. And it's easy steps from here. If you're solving, you just leave it this way and you square root. So to solve, leave as is and square root to solve. Okay, so that would look like this. X minus 3 whole thing squared equals 20. Let's square root both sides. Square root. And we'll get x minus 3 equals square root of 20, but plus or minus. And then just add your 3. So this whole process should be fairly familiar. And we'll get x equals 3 plus root 20 and 3 minus root 20. That's the plus or minus, okay? So if we're solving, just leave it alone. You don't need to move stuff around. And you just go ahead and square root to solve. If I said write in vertex form, so that's this other option. What do you think we do? Do you see how close it is to vertex form? For vertex form, Just move the right side back. So it will look like this. X minus 3 whole thing squared equals 20. And we'll just subtract 20 from both sides. And you guys, this is cool because you're going to see, I think you're going to pick up on this right away. Where's your vertex? 3, negative 20. Cool, right? So we just took standard form and wrote it in vertex form. So vertex is at 3, negative 20. So you're going to have those, when you do completing the square, you're going to have those two options. And again, it just depends. The problem might say write in vertex form, or it might say solve. It just depends on what the problem wants us to do. But you have two options after you're done completing the square. Completing the square stopped at this step. We had completed the square, and that's why we were able to write it with parentheses and squared. Okay. Questions? We just threw a lot of information out there. How'd you do? Just feel like you followed it? Okay. Why don't you try one? And I know we just have a minute left, but let's just go ahead and try this. We have more than a minute. We have a few minutes, but it's not super long. Okay. You can probably knock that out in the time that we have. Okay. All right, let's go ahead and check. So subtract 10 over. Okay, b over 2 in this case is negative 5 over 2. b over 2 squared is 25 fourths. So we're going to add 25 fourths to both sides. Okay, now we can factor this one out. Remember, it's always going to be x and then minus or plus, whichever sign you have, b over 2, whole thing squared. And then over here, negative 10 plus 25 fourths. What is that? Negative 15 fourths. Okay, and then I said solve, so we would square root both sides. And it's going to be kind of from there a little bit ugly, but plus or minus square root of 15 fourths I. And then we have to add 5 fourths. So on your sheets, you're not solving, but writing in vertex form, do 24 to 29, please. 24 to 29. No. Do 24, 25, and 28. I'll put it on there, 24, 25, 28.